Good almost evening, everyone. My name is Seth Shumate. I'm the inventor of the technology that helped us form our company, Pika Solar. And joining me today is Matthew Young, our Senior Vice President of R&D. Some of you have heard this before, but he's also known as the guy that gets things done. So I feel like a little bit of a repeater there. Okay, so our company has won 2 Sunshot Awards and also raised private capital, and that was to get our technology to a point where it could be fully manufacturable. And so right now we're looking for $3 million to build a full-scale, high-throughput tool that's ready to go into solar cell manufacturing. So last year there were 10 billion solar cells made, and each one of those has a common thread. The front surface has some electronic defects which limit the efficiency by about 15%. Our technology directly addresses that. We use atomic hydrogen to treat the surface to make it think that it's a really high efficiency device. Now that may not seem like a huge boost, but in a $35 billion market, that's just over a $5 billion opportunity. So a byproduct of our technology is that we enable solar cell manufacturers to actually use less silver than they currently do. And this is important because silver is the second most expensive cost in a solar cell. So that, coupled with the efficiency gains, this is worth about $140 million to the average size manufacturer. And this is why industry experts have told us that we have the potential to revolutionize the manufacturing of silicon solar cells. So this is my favorite graph, and it's going to be really hard for me not to
You're down here.
Look up there. Anyway, the red curve is the response of an average solar cell. You can see it's not 100%, so it's not perfect. We were able to take that solar cell and make it respond pretty perfectly to the different wavelengths of sunlight. And it matches the world record N-type solar cell. The problem with this world record is that it took them 4 hours to make the top surface, which is not manufacturable. Our process took about a minute. So the solar market is an international market, and we have to be very careful about our IP since most of the manufacturing is overseas. We have engaged with BSTZ, a Silicon Valley IP firm, who has clients such as Applied Materials and SunPower, who operate heavily in the solar space. We currently have filed 2 patents, and we expect those to be broken up into about 5 so we can create a thicket of patents around our technology. And our law firm thinks we're in an enviable position because our technology leaves a unique electrical fingerprint on the solar cell, which makes it cheap and easy to detect if someone's infringing on our patents. So our business model is extremely simple. We build equipment, we sell it straight to the solar manufacturer, and also charge them a licensing fee. So remember, 10 of these tools could enable $140 million of increased value to that solar manufacturer, which for some of them is the difference between bankruptcy and profitability. From that, we'll take $22 million with a $10 million recurring revenue stream every year. And our industrial partners that are partners with us on the Sunshot say that this is a reasonable business model. So that's what we're doing, and now I'll hand it over to Matt to tell you more about us.
Thank you, Seth. So any world-class technology needs a great management team to get it out to market. Our CEO, Douglas Hutchings, has spent the last 5 years in the solar industry in executive roles, and he's raised $4 million to date. Of course, Seth Shumate's our CTO, and he was the primary inventor of the technology. And now, because of our ability to execute on our technical plan, we were able to recruit Rick Schwerdberger as our COO. He's taken a similar type business model in an adjacent industry, and he built a billion-dollar company in less than 4 years. I'm Matthew Young, the Senior Vice President, and I actually am working on my PhD on this technology. So any core management team needs a great group of people behind them to help advise. We have an excellent board of, we have an excellent corporate board as well as scientific advisors to help us push this out to market. These individuals have actually taken ideas in the solar industry and walked them through to an exit or an IPO. So any high-tech product needs a lot of external validation in order to get it to market. And through our Sunshot Award, we've been able to leverage and develop a huge network of partners. One of those individuals, the National Renewable Energy Laboratory, was able to take and give us the opportunity to pass key reliability milestones that without those, you don't even get into the market in the solar industry. We've also working on an internal cost model with them, and they've told us that our numbers look very good and validated that and compared it to the standard industry numbers. In addition, a very valuable partner that we have is Georgia Tech, based right here in Atlanta. And actually, after our presentation this afternoon, we were able to go over there and do some real lab work with them and pass yet another one, well, hopefully, it has to go through the DOE. But the results were very good. They're acting as our third-party validation, and they said that our process gave a better response than the baseline. So that's very good news for us, for sure. The other thing we were able to recently do this past summer was take our process to an industry partner, and we were able to test out our process in a high-through manufacturing scheme and found that it's compatible with that. So all of this technical validation has allowed us to get on our first customer's technical roadmap. But we realize it's important not to stick with just one customer, so we're actually engaging in cell exchanges with a number of other manufacturers and have attained 4 letters of intent to date. So these aren't my favorite graphs to present, being as how I'm kind of a techie. However, I should say that by the year 2018, we expect a little over $100 million in revenue. Now, you might notice that's a 75% profit margin, which seems quite a bit high, and I want to apologize. We didn't get the opportunity to update this graph between the afternoon session and now. That only includes our COGS. This graph didn't update properly, so more realistic profit margins 40 to 50%, and that's been validated by NREL. To add to that, we have good margins, obviously, and those increase with time because of the licensing revenue built into our business model. So it all started with an NSF Phase 1 SBIR. With that, we were able to get the technical results necessary to be awarded our first Department of Energy Sunshot Award. And because of our ability to carry out all of those milestones, we were awarded the follow-on funding, the Sunshot Tier 1. And we were able to couple that with $1.2 million in private and public funds. And basically all this funding is taking our lab technology and getting it ready for a manufacturing environment. So that's part of the reason why we're here today. We're looking for $3 million to fill out our next fundraising round, and we anticipate being able to complement that with another $2 million from yet a third Sunshot Award. We'll couple that with some equity and debt capital of $8 million to round it out for $13 million to go from where we are, manufacturing ready, to a high throughput piece of manufacturing equipment capable of serving the solar industry. So we're moving very quickly. We're building a lot of momentum. Seth and I and our other team members have basically lived and breathed this for the last 3 to 4 years. Most recently, we were awarded the MIT Clean Energy Prize. And just after that, at the Rice Energy Forum, we were named one of the most promising companies. And some individuals have dubbed the Department of Energy Sunshot Incubator Awards as the Nobel Prize of solar startups. And I just want to add that we've actually won 2 of those back-to-back, which is something only a handful of companies have done. In addition, we were named a 2014 Edison Award winner. So I hope you enjoyed our presentation, and hope you might be able to join our team possibly. And we look forward to any questions you might have, so thank you very much.
So what is it that someone that wanted to manufacture with your technology, what would they get from you?
We would be building the tool, so they would get the tool as well. We would require a licensing for the recurring revenue because this piece of equipment is providing a lot more value than a standard solar industry piece of equipment would. Those are more commodity. There are several providers. Since we're the only provider of this technology, we think that that would help. But basically we'd get them.
So what would it take for them to modify their manufacturing footprint to actually use this?
It can possibly be done in line with everything else they have. We have talked to the engineers at Suniva, which is a local company, and they said it would basically be switching 2 pieces of equipment. It wouldn't be a very big deal.
Who exactly you're selling to? What are these companies and how many of them, and how would you sell to them?
So we're selling them directly to solar cell manufacturers. The average solar cell manufacturer will likely need about 10 tools right now. That, of course, is growing as the industry grows. The top 5 manufacturers all will need about 10 tools, so that's 5 potential customers with 50 potential tools.
Have you talked to any of the top 5 yet?
Yeah, one of our partners on the Sunshot is number 2 right now.
So who manufactures your machines? Is that something you will set up a capability for, or will you outsource that?
Right, so we're planning on scaling up and manufacturing the equipment ourselves based in Fayetteville, Arkansas. That's why we have Rick on our team. He's done the similar type thing with another company, and he also does business in China, so he's a very valuable asset when we get to that stage.
And what's the time frame and money for getting that set up?
That would be $3 million right now. We think once you get pre-orders for tools, that can help finance the actual build of the tools and the overhead that it takes to do that. The time frame, I think, was the end of 2016 to get the first tool on our customers' hands.
By winter 2016, we want to be in our first customer's pilot line, hopefully roll out the tools in 2017 sometime.
Who do you see as your competition moving forward as you guys roll this out?
Right, so our technology is, in the industry term for it's a selective emitter. There are other selective emitter technologies, but they kind of just scratch the surface in solving this key problem for the solar cell manufacturers. And that's why sometimes we like to call ours the super emitter.
What is the biggest challenge you have in terms of the execution of the strategy? You've been working at it, it sounds like 3 or 4 years at this point. I'm just curious, as you look forward, assuming you got the capital, what's the biggest execution risk?
I would say maybe the thing that keeps me up at night most is just market shifts. Obviously, solar's gone through quite a volatile market in the last couple of years, but that's steadying out, so that kind of calms my fears down. However, I don't think solar's going away anytime soon. It's growing at a steady 30% pace. Even the most conservative individuals think that will continue for the next 5 years. Has an exponential growth curve over 2 decades, so I think maybe actually we'll be okay there.
Yeah, and we're trying to spread out our customer base as we speak, so to try not to put all our eggs in one basket, so to speak.
Are your customers domestic here, or is it domestic and international?
One of our partners is domestic. Most of the manufacturing is in China or Taiwan, so 80% is in Asian markets. That's manufacturing. Now that our patents are going to cover most of the end user markets, so there are regions where we would be able to prosecute in case anything comes up.
Is your primary channel just solar cell manufacturers, or are there other potential channels for your technology?
Currently, we're just focusing on solar cell manufacturing. We haven't had time to figure out whether or not this could be applied to other technologies, perhaps LEDs, but we have no experimental evidence to suggest that right now. So just focusing on getting it to our first customer and addressing the first market at hand.
Let me say it's very impressive sounding technology. If it works and you scale up and you build these things, how viable is your business plan if you lose subsidies and mandates for solar, at least in this country?
So in the United States right now, if you install solar panels on your roof, you get a 30% rebate. In 2017, that goes to 10%. However, the United States is, I don't know, maybe 6% of the entire global solar market. So, and as Matt said, it's expected to increase. So.
Yeah, so the industry's grown really large. Some people even say within the industry, we don't need subsidies anymore. The cost is going so far down that it holds us back in a way, right? So I think in terms of subsidies, we'll be okay even if they get taken away. We'll still have a market to sell our tools to.
You mentioned you've got a need at some point down the road for another $8 million of capital. How much, if you could detail kind of what your thoughts are in terms of raising that capital, debt versus equity, and how you guys are thinking about going to market.
So
as much debt financing, depending on the pre-order condition that we can get from manufacturers. Rick Schwerdtberger was able to build his entire company off pre-orders for the sapphire growth industry, and I think at their peak was doing $50 million a month in tools. So if we play our cards right and we get a little lucky, then we might not have to raise any more than that initial $5 million. Thanks.
Thank you very much.
So we'll have a couple minutes pause while we transition to the next team, which is Guru Skins from the University of Tennessee. Team members are Jake Rheude, John Bourne, and Dustin Giltnane.
You're there to catch it if it falls, right?
I don't think it will. Huh? I don't think they will. Lynn's got his camera up.
Well, good evening. My name is Jake Rheude. This is Dustin Giltnane and John Bourne, and we're here with Guru Skins, where we facilitate the interaction between two mutually expressive communities of graphic designers and board sport participants. Now, we do this through our crowdsourcing platform that allows us to engage with our target audience at a much deeper level while operating incredibly lean. Now, there are two terms that I want to define real quick off the bat, and the first is crowdsourcing. What we mean by crowdsourcing is simply, instead of having an internal design department, we solicit designs from artists from all over the world. The second term that I want to define real quick is board sports. All we mean by board sports is essentially any activity where you're riding on a board, be it snowboarding, skiing, wakeboarding, surfing. You guys get the gist. So when you think about the board sport market, you probably think of a younger, liberally dressed crowd, and you'd be right. You can't turn on the Winter Olympics or an X Game event without seeing people dressed in neon-clad one-pieces with funky hats, mohawks, and tattoos. And while John, Dustin, and myself don't have any visible tattoos, unfortunately for me, my choice of style while skiing and snowboarding has been well documented and, at times, rightfully so, used as blackmail. But let's talk about the market opportunity that exists. You don't have to grow up immersed in board sports to understand that these are incredibly expressive activities, where what you wear, how you look, and the style by which you get down the mountain is all a part of this personal brand image that we're all trying to portray. Now, they're also equipment-intensive sports, and the most important piece of equipment that we own is the actual board that we're riding on. So in talking about snowboards, you're going to spend $400 to $900 on a new snowboard that has a static design. You can't change it out from year to year. And furthermore, after a season or two of use and having people running over your board in the lift lines, the value of your board's been completely diminished. But in the mass customized world that we live in today, people are actively expressing their want and desire to be able to take this vital piece of equipment and customize it to make it their own. Furthermore, board sport manufacturers tap into this creative market by hosting open source design competitions, for which they'll receive hundreds, if not thousands of designs, only to choose one or two that they actually implement into next year's production line. At Guru Skins, we tap into this same creative market, but we give them the opportunity to see their designs come to life literally overnight. Now, there are three main pillars of value that we provide to the actual boarder, and the first is this expression. Rather than being stuck with the same static design, you can change the look of your board from year to year, season to season, or even trip to trip. The second big value is the ability to protect your board. In the same way that a clear brawl protects the front of a new car from rock chips, our Guru Skins protect your used or your new board, extending its life and increasing its resale value. And the third pillar is a social pillar. Because we've received designs from artists from all over the world and then connect them with our customers, creating an interaction that otherwise wouldn't exist and giving these artists a way for their artwork to actually come to life. Now, in talking about the global market, there are over 162 million board sport participants. This is a huge and affluent market. We've been primarily focused on growing in the United States, of which there are 43.5 million participants. But to narrow that down even further, our primary target audience are the 25 million Gen Y board sport participants, people between the ages of 18 to 35. These are the most expressive group. And they also 34% of them represent multi-boarders, meaning they ski or snowboard in the winter and then they wakeboard or surf in the summer months. But Gen Y is a really difficult market to capture. A lot of businesses have struggled with this. I mean, we're the fastest growing demographic and we are the most connected generation ever. Yet, we have the least established brand loyalty and traditional marketing methods just don't work on Gen Ys. So the question becomes, how do we engage with this target audience?
The answer to that question is our distinctive competence, and it's found within our business model. Let's be honest, vinyl wraps aren't new. Board sports have been around for decades, and starving artists have been around for millennia. What's new about Guru Skins is the way we take these three elements and then combine them to create something new, and that is our interactive community. Our crowdsourcing business model ensures that our product creation and forecasting, as well as our revenue generation process, are all highly influenced by our community. And you're probably wondering how that works, and it starts with the design creation. The artists create the designs, but the ones that are chosen to put up for sale are ultimately decided by our community, which are boarders. On the revenue generation side of it, for every skin that sells with an artist graphic on it, that artist gets a royalty. That highly incentivizes our contributing artists to go into the marketplace and push the product, and essentially pushing our brand. So with such a unique business model, we're going to have a highly skilled management team that understands the target market. We're going to have experienced advisors that can help guide us as we grow, and we're going to need to develop strategic partnerships to help accelerate that growth. Our management team starts with Jake Rheude. He's a serial entrepreneur with 4 prior startups and is currently finishing his MBA with a focus in supply chain management and entrepreneurship and innovation. For brand management, we're working with Sydney Falkerson. She's currently the marketing manager at IMC and has extensive brand management experience. My name is Dustin Giltnane, and I'm handling the operations. My background is in project management with the Tennessee Valley Authority. I'm currently finishing a dual MBA, MS in nuclear engineering with a focus in entrepreneurship. Our finances are handled by John Bourne. He has an undergrad in finance and is currently finishing his MBA with a focus in financial management. For our advisory team, we've got Lynn Youngs, Glenn Swift, Pat Richardson, and Tom Graves. These 4 gentlemen head up the entrepreneurship program at our university and have extensive experience ranging from serial entrepreneurship all the way to international investment. But now that our advisors have helped us launch this company and get us off the ground, now it's time for us to really push our growth, and that's going to be done through strategic partnerships. That begins with production and fulfillment. Our production and fulfillment is being handled by Bill Baglio. He has more than 25 years experience in the printing industry. Now for web development and search engine optimization, we're working with Devin Campbell. He is an SEO strategist and has extensive web development experience. To get us in front of our consumers, we're working with Ricky Brooks. Through his business background, he has developed extensive relationships and a highly developed network in the where our target audience resides in the Rocky Mountains. True to our Gen Y nature, we're also working with Art on Board. Art on Board is a non-for-profit community engagement organization that also operates in this niche space of combining art with board sports. So we've got a management team that really has their finger on the pulse of this target market. We've got strategic advisors that have helped us get off the ground, and now we're developing relationships to help accelerate our growth. But what do we look like from a financial standpoint?
When evaluating the potential return on an investment, Warren Buffett said, "Price is what you pay, but value is what you get." So let's talk about the value that Guru Skins could provide a potential investor. By focusing on winter sports, we could be exposed to the adverse risk of seasonality. However, by covering all board sport designations, we can sustain our revenues year-round. Additionally, our business model is inherently incredibly lean. We have outsourced production, and we're operating in a virtual space. Depending on the type of the board, we're using a selling price of $40 to $70 per skin, and that's less than the price of a lift ticket or the cost to fill up your boat with a tank of gas. The cost of goods sold is $10 to $20 per skin, and that includes the cost of vinyl as well as all of the packaging contents. And this gives us an attractive unit margin of 70%. As Jake mentioned earlier, our target audience is the 25 million Generation Yers. And the 34% of those that make up cross-borders, by targeting those, we can create repeat customers that make multiple purchases across product lines in different seasons. We've projected 4,000 in unit sales for year 1 and growing those to 250,000 by year 5. And using these forecasted numbers, we projected to be profitable by year 2 and to earn $5 million in net profit by year 5. With an initial investment of $150,000, we projected a 5-year net present value of $4.6 million, and this also gives us a 150% IRR. But financial projections are only as good as the assumptions that back them, so I want to stress that everywhere an assumption was made, it was highly conservative. But at the end of the day, Guru Skins isn't just about financial performance, it's about cultivating a community. Thank you.
Can you walk me through how you're going to get to this $2.25 million Gen X? I'm not sure I understand exactly how you're going to grab the market.
Absolutely. So essentially our go-to-market strategy is to get involved with bloggers, thought leaders, and influencers in the arena. So GoPro uses a model where anyone can apply on their website to be sponsored by GoPro. That may mean you receive a check for $100, a couple accessories, or a whole new GoPro. But we want to follow a similar model where we can engage with people who have a couple thousand followers on YouTube, or the people who are already going to be taking videos of themselves doing snowboarding tricks or wakeboarding tricks, and in a way sponsor them. We have a very low cost of goods sold, so it doesn't really hurt us financially to be giving these away for free to those thought leaders and generate a lot of impressions to our target audience. That, I mean, everyone's seen the impressions funnel down to sales, the ultimate goal of driving sales.
Any search engine optimization initiatives?
Yeah, so that's where Devin Campbell comes in. He is a very brilliant web developer who pairs web development with SEO. And so none of us are experts in that, so that's why we've gone to Devin. We've brought him on to really make sure that our SEO is aligned with our website.
So you're following the bloggers and others that are influencers in the board community, is that the thought? And then they would be mentioning your products or mentioning your company or somewhat gaining some exposure for you through them?
Right, the whole point is to generate impressions in the community.
What's the risk to the materials and the adhesives not holding up in the conditions they're going to be used in?
This is an incredibly strong material. It's a 3M vinyl that we pair with an over-laminate. So we spent all winter testing out, would it work in the snow and in the cold? So the adhesive will actually stay adhered in negative 30 degrees and then up to like 180 degrees. So we've got all the extreme temperatures kind of taken care of.
And does the manufacturing technology to make all that currently exist? It's just a matter of going out and buying time on the press? Is that?
Yeah, and there's nothing proprietary about the vinyl itself.
Or the adhesives? Is that
Correct.
Have you tested the market in terms of having a pilot with some of your followers to see if this is sticky?
That's exactly what we're doing right now. So we spent the summer pulling together a community of artists with an incredible response. We were actually kind of overwhelmed and had to take a step back with the number of designs that we had submitted to us. So we used that, and then we built what we have up right now is a minimally viable website that started to generate minimal sales. But now the goal is to, exactly what you said, it's essentially, this is our pilot. Make sure that the market exists for the board sporters, and then build up that website.
Can you help me understand the ramp up? We're going from 4,000 units to 250,000 units over a period of 4 or 5 years. Two questions. One, what type of capital do you need to execute the plan? And I'm just trying to understand, I know a lot of your manufacturing or whatever is outsourced, but just your capacity to fulfill that kind of order level.
Can I take them in reverse order?
Sure.
So the manufacturing right now is all done out of a facility in Ohio. We have that one facility, and it doesn't take us very many orders to reach capacity. Literally 4 orders a day would be our economies of scale, because you're just lining them up on a 52-inch printer. As far as ramping up production, there's nothing proprietary about the vinyl itself. Another printing company could buy the same vinyl and pair it with our overlam. So the next step would be to set up another facility in Denver, for example, if we're getting a lot of orders from the Rocky Mountain areas, so that we could direct orders to either an East Coast fulfillment or a West Coast fulfillment so that they can get it to the customer faster, depending on the zip code of the final destination. And then I believe that your other question was about
Just capital,
go-to-market.
basically. I'm just trying to understand your capital needs as you execute your strategy.
So the great thing to date is that because we're crowdsourcing, we don't have a lot of expenses up front. We've been able to do all of this testing and build the website with less than $6,000 in capital. What we're asking for is $150,000 that is going to essentially give us a huge push for the marketing and really get us the number of impressions and therefore unique visits to the site that is going to drive up sales.
Thank you.
How do your strategic partners participate in your business model?
So our core competence, we're not trying to be a printing company, which is why we've gone to Bill Baglio and his facility, and they handle all of the actual production, kitting, and fulfillment. And then, like I said, none of us have the web development or the SEO skills, so that's why we brought in Devin Campbell. And then the next phase is to try and reach the market. So we've brought in people who have relationships with key suppliers out west. We've essentially kept our core competency around building this community.
So these guys are basically your suppliers.
In a sense, yes.
Okay.
How do you make sure when you get these crowdsourced designs that you're going to base your revenue stream on, that you've got the intellectual property rights to actually execute against those and won't be embroiled in a bunch of lawsuits?
Will you ask that again? I'm sorry, I didn't.
So you get these crowdsourced intellectual property ideas, right? Mm-hmm. So how do you know that the people that are actually bringing you those ideas own the intellectual property for that, so that once you go out and start making sales, somebody doesn't say they stole my design and you guys don't have rights to it?
That's all kind of outlined in our terms and conditions, where essentially the artists who submit it to us are saying that this is an original work of art that they created and they don't have it licensed anywhere else.
So if you get the letter from the law firm saying cease and desist making your most profitable design, how do you guys deal with that?
I think the immediate reaction would be to take it down and then to investigate with a lawyer. None of us are a lawyer, so we would bring someone in. But.
And one other question, can you do one-off designs? So could someone just say, hey, I want this board, I want you to make it for me, or do they have to be chosen that you mass produce to make the business model work?
Well, we'd be more than happy to do a one-off for a premium price. Is that it? Oh, thank you very much, guys.
And we'll have another short break while the third and final team prepares. We will have Tri-Fusion from Texas A&M University.
Take these back,
Team
please.
members are Brandon Sweeney and Blake Teipel.
Do you want to try this? Yeah. Okay.
Can we check the feed? Can we see if it's working? Okay. Cool. Great. What's the timer down
Is the
here?
timer going?
Oh, 10 minutes.
Good evening. 10 days ago, we visited the Center for the Intrepid in San Antonio, Texas. The CFI is one of the top 3 facilities in the United States where America's veterans may go if they need to be fitted with a prosthetic device or receive rehabilitation. We were hosted by the center's medical director, an orthopedic surgeon, and while we were there, we met with a young man named Matt. Matt lost most of his right leg overseas. He said, "Doc, when can I get my new leg?" "I'm ready, Doc." You may see, as we do, additional applications for our technology, our patent-pending process, in areas like military, automotive, and aerospace. But we believe that the first and best viable path to market is served by focusing on the healthcare industry. Because you see, Matt is just like millions of other Americans who've lost a limb for a variety of reasons. But unlike Matt, these folks also have lost their financial freedom because biomedical devices are very, very expensive. It may surprise you to learn, as it did us, that a device as simple as a prosthetic leg can cost in excess of $30,000. Medicare reimbursement rates are typically limited to $3,000 of those dollars, and even more troubling, these devices wear out, needing replacement every 3 to 5 years, so users who can afford to buy one have to replace it very often. So wouldn't it be incredible if we could build and sell a durable, custom prosthetic device affordably enough so that healthcare contributions covered everything? We have a technology that'll do just that. Our first prototype is a custom-fit, one-off device that we 3D printed. It uses a modular, low-cost knee joint, providing a range of pricing opportunities. We can price our device as low as $3,000, which is a tenth of the current pricing. If somebody wants to run, they can use a different off-the-shelf knee. There are a variety of options with our technology. My name is Blake Teipel. I'm a PhD candidate in materials science and engineering from Texas A&M University.
And I'm Brandon Sweeney, also a PhD candidate in materials science and engineering from Texas A&M University. And we are Trifusion Materials. Now, you may know that 3D printing has been used for prosthetic devices in the past. The problem with this has always been that the materials are too fragile to be used in load-bearing applications. This is because when you look at a 3D printed part, it's built up in layers. And when you use that device in everyday life, it pulls apart, cracks and pulls apart like a deck of cards. Trifusion is a patent-pending technology that solves this weakness. We start with a standard 3D printer filament, and we apply a thin coating of carbon nanotube ink. When microwaved, these nanotubes heat up rapidly and weld the whole component together. We've already increased the toughness over 10 times that of standard 3D printed parts. You see here is a prosthetic socket that was made with an current technology. It failed in an area of high stress. Our devices will not fail in this manner. We have validated the materials and proven that our device is tough. Next, I'm going to show you exactly how we made our device. We start with 3D scans of a patient's limb geometry. My wife donated her leg to science for this scan. This was done with a cell phone camera. We took multiple images and stitched them together using advanced software. This got us precise resolution and detail of the limb geometry, and this can be done for any patient. Next, this is converted into a mesh, and this can be adapted for areas of hard and soft tissue by a certified prosthetist. This is what's critical for making that a comfortable fit. This is where our business will really start. We take that geometry from a prosthetist and we converted it into a finalized CAD design. This is the final form of our prototype. And really, this is the key point of our technology. We go from this design to the finalized device in one step. We cut out an enormous amount of labor that normally takes weeks to do, and using our prototype to printed final design in one step. And you can see here that our printing process takes only a few hours, leaving us with the final design. And next, I'm going to show you the secret sauce to our patent-pending technology. Up here is a microwave probe that's heating our device. It's a focused microwave applicator, and you can see that part is heating up, fusing, and welding together. This is the key step to our process, and this is what all other 3D printing technologies have lacked in order to produce a durable device. We validated our materials and have proven that they will withstand everyday use. The final design is ergonomic and elegant. We've talked to multiple prosthetists and experts in this industry, and they've all indicated that our technology is what they want right now. Additionally, we met with 2 VPs at Hanger Corporation, the largest manufacturer of 3D printed components in the United States, of prosthetic devices in the United States, and they told us that our technology solves a major pain point for them.
So in addition to our experience in researching advanced materials and materials science, we also have experience in manufacturing, product development, and mechanical engineering. Brandon worked for the Army Research Lab in Bethesda, Maryland, in advanced prototyping, quadcopters, you name it. I worked for John Deere and for Caterpillar for quite a few years in a variety of product development roles. I was even part of a team that helped turn a greenfield into a manufacturing facility, bringing 80 jobs to Central Texas. This isn't quite enough experience, though, to launch a new venture, and we realize that. We've assembled an advisory board with a mixture of high-quality medical folks, finance, and serial entrepreneurs to help get Trifusion off the ground. In addition, we would seek your help and others to add sales and distribution folks to our team. From a pricing standpoint, let's talk dollars. Our material costs for this device are lower than $30. There are a variety of overhead and other charges, but our total device cost would come in lower than $400. This helps us supply the device with ample margin opportunity to deliver the cost as low as $3,000. Again, off-the-shelf components allow optimization and customization. If somebody would like to run, if somebody would like to do a variety of activities, we can just source an off-the-shelf part and fit it in with our design. But the margin opportunity is ample, and we would drive high sales revenue, high volume to Trifusion using this pricing model. Every year in the United States, there are 100,000 biomedical devices. At an average price point in today's dollars, that's $30,000 each. Our market, just for prosthetic devices in the US, is $30,000, or excuse me, $3 billion. And here's really where we need your help. The seed money we need to launch Trifusion is $1.3 million in total. We have already received phase 1 funding from the Army Research Office to develop the materials science. We've written follow-up funding for the follow-on money, $250,000 in a secondary grant. We have $100,000 tentatively committed from a private party investor. In addition, we would buttress these funds with National Institute of Health grants that we're writing in collaboration with the CFI. This would be $500K, so we need only $400K more from private parties to launch Trifusion. This would be the first 2 years, during which time we do R&D, prototyping, and testing in conjunction with the CFI. We'd hire a staff of 3 full-time people, source the materials and the equipment needed to launch the company. Somewhere in between years 2 and 3, we would set up for a Series A round of fundraising at about $1.5 million. During that time, that would get us launched in through the 4th year when we would begin to cash flow the company. During that time, we'd do pilot builds, customer trials, and production builds. We'd add 2 more people to the staff, cover legal and accounting, and we would build our devices and test them in association with good manufacturing and good clinical practices per ISO 14155. In the 4th year, we could conservatively sell 500 devices at our price point of $3,000 per. This gives us a revenue opportunity of $1.5 million. That's just the 4th year, just the United States, just biomedical devices. We could easily cascade production, bringing additional scale to the table to meet the ramp up as needed. First 3 years are product development. The next years 4 through 10, we could conservatively estimate company growth at 20% year on year. The market growth for prosthetic devices is actually growing. There are a variety of patients who, unfortunately, due to diabetic neuropathy and other issues, they lose a limb, and so the biomedical device industry for prosthetics is growing in the US. We could outpace market growth because of our attractive pricing, driving revenue opportunities to Trifusion.
Here's a concrete example of how we're ready to improve lives and drive sales to our business using our revolutionary technology. If you consider a patient who's young, is in need of a prosthetic device, they may end up spending over $450,000 over a lifetime. Instead, we can use Trifusion technology and cut this cost down to about $45,000. This gives us an enormous competitive advantage in price and production time. we'd like to leave you with this thought. Every 30 seconds, a person just like you and me loses a limb. In the time that we've been talking, that's 20 people. They are ready for our technology. They're ready for their freedom. And together we can launch Trifusion. Imagine what other industries we can disrupt with this technology. Aerospace, automotive, military. Thank you.
Tell me how you want to go from market to sales. Understand the competitive advantage you have, but
Sorry, I can't hear you.
how are you looking to go to market for sales?
Are we looking to go to
No,
market?
how are you looking to go
How?
to market?
Yeah. So
I didn't
when
see
we
that in there.
Sorry, yeah. When we met with the folks at Hanger, for example, they said, hey, would you guys even be interested in licensing, sub-licensing this to meet a specific segment of the market? And we said, of course. They're going to give us CAD models, for example, of the socket, and we can print it with our material, and then they would be able to test it, helping us validate the process. We have a real passion for biomedical devices. I don't want to lose that. And if we develop the material in conjunction with the CFI, every application that we go to market after that would be military developed, military tested. That would have a really nice market opportunity for us.
So Hanger currently produces prosthetic devices, and
Yes, sir.
you would be a supplier to them possibly, and they would probably license or utilize your technology?
It's a possibility,
that's,
yes.
that's wide
Are
open.
there any
option.
other market opportunities you sort of investigated of going to market?
Absolutely. So again, I said aerospace, automotive, and military. I have a military background, and they're very interested in this technology for rapidly producing new devices. And the automotive industry, they just 3D printed a car. Imagine what they could do if they had this technology to make that car strong enough to deliver to consumers.
Have you looked at any other go-to-market for the healthcare vertical, though, in addition to Hanger?
Yeah, there are orthotic device suppliers and orthopedic device suppliers to whom we could also supply our technology and our materials.
What is what is the proprietary technology that you guys hold that someone couldn't replicate?
So the secret sauce of this whole technology is the coating process, the carbon nanotechnology that's used for that heating process, and the integrated microwave technology that goes into the actual 3D printer. I'm the primary inventor of that technology, and that's really where the IP lies.
So from a material standpoint and the production capacity, the 3D printer, how expensive are those things? How available are they? How many different sources do you have to get that from?
To give you an example, I started this research with a 3D printer that cost $900. I got it off of Amazon. But really, to take this to the industrial level, we will team with or build our own industrial-style 3D printers. These can cost between $10,000 and $20,000 for the higher end that provide the reliability, and we'll integrate our microwave technology into that printer.
And then the materials you use to do that you actually build it up with.
That's an exciting part. The materials are incredibly cheap. We put on, for 1 kilogram of spool, we add 1 gram of carbon nanotubes. So that's 1/1000th of the weight percent. So we're bumping up the cost of the materials only 7% over current technologies, and they're already cheap.
So how do you guys plan to test this? Do you have partnerships lined up? Because that seems like that's going to be the riskiest part to me at this point. So how are you going to manage that risk through the process?
Yes, ma'am, that's great. I'm glad you allowed us to clarify that. So the biomedical devices, these will be tested in conjunction with the Center for the Intrepid. That's a top 3 facility, and in fact, they may bring additional scale because there's 2 other facilities. The Center for the Intrepid is in San Antonio. There's one at Walter Reed, and there's one in San Diego. So we would actually be able to test and validate our new technology really rapidly. We could get, they all have certified prosthetists who are there, and their comment to us when we met with them was, if you guys can get us out of carbon fiber, which is a known carcinogen, we are happy to adopt your new 3D printing technology. So they're ready to go.
I am fascinated by this whole concept. The question I've got is, how did you determine a price point at $3,000 when it seems like your competition's at $30,000? Why not 5, 6, 10? I don't know, but I'm just curious. How did you get to 3?
That is an awesome point, and we're glad you brought that up. So we said that our pricing could be as low as $3,000. As you saw, our margin opportunity is between 600% and 700% at $3,000. It's a low-cost, almost zero labor model. 3D printing is automated. But we could work with you, other folks, to help determine appropriate pricing models based on the activity level that people would like to use. So again, if you would like to run A current prosthetic device is $30,000, no running. If you'd like to run, it's about $100K. So if you'd like to run with our device, again, just cut that in by a factor of about 10, and so $10,000 device, and you'd have your pricing.
Thank you. And a follow-up question. I think it's great you reached out to talk to Hanger. They've got a great reputation in the marketplace. If I were on the Hanger side of the deal, if I really bought into this, I want to take you guys out of the market very quickly. Why wouldn't they jump in front of all of this capital raise and basically partner with you today?
They're interested in partnering with us right now. That was really, and we can even test the device with them. They said that they could send us a file, we'll print it out, send it to them, and they can test it and validate it. So we're absolutely interested in licensing the technology early on, and we're also passionate about developing this and bringing it to the market ourselves if we have to. We don't want to see this technology buried.
And the beautiful part about sublicensing the technology, because it's really a material science technology at the end of the day, we could sublicense for the manufacturing of biomedical devices to Hanger. That would allow us to pursue rapid prototyping. When I worked at Caterpillar, we couldn't 3D print functional prototypes. They weren't strong enough. But we could go back to the automakers, the military folks, and the aerospace folks and say, hey, now we have 3D printing that can actually build you a functional prototype.
Do you require FDA approval for this device?
This is a tier 1, or I should say actually a class 1 device. And all it has to be done is developed in conjunction with good manufacturing, so GMP and GCP. That was a comment again from Hanger. In addition, we can de-risk the development by collaborating with the CFI, the military folks, veterans and so forth, and the VA, by the way. We met with the VA, a prosthetist from the VA. And he said that military folks provide an opportunity to test and validate without requiring FDA approval beforehand. So that would be
so there's no FDA approval hurdle.
The military is not subjective to those standards. So we
what
can
about
get
outside of the military? Because that market you put up there was bigger than the military, right?
Could you say that again?
The market for prosthetics was bigger than the military. Right?
This is a great point. GMP and GCP, those are procedures that are specified by FDA. But for a class 1 device, the burden of efficacy is much lower than a class 2 or a class 2 or a class 3 device, something that's in vivo. There's no 10-year period that you have to go through, for example, with a class 1 device. It's all ex vivo. These materials have actually been validated. In fact, carbon nanotubes have been cleared already by FDA.
We have experts on our advisory panel who can help us with these issues and bring them to market. People in the military who have been prosthetists, and that's really the people that we're going to rely on to help us with those issues.
Thank you.
Thank you.
Thank you.